All right, so we're going to be learning about functions today and function inverses. First thing I want to do is bring your attention what a function is defined as. So this right here is called a relation. It's relating values of x with values of y. A relation is a function if each x leads to exactly one y. That's the definition of a function. So if each x in the relation leads to exactly one y value, it doesn't matter what y value it is. It can be the same y value for every single x. It just has to lead to one thing. If that happens, it is a function. So I'll give you a moment to copy that down.
Is that relation?
Yeah, the relation is just a way to relate x and y. So it could be a table of values like this. It could be a list of ordered pairs. It could be an equation. All right, so it's just something that has x and y in it that relates the variables x and y in some way, shape, or form.
Is that function or? I'm sorry, I'm blind.
I
Is it
think
function or fraction?
Function.
Okay.
I could write it prettier too. Let me try.
I'm just like curious.
There we go. All right, so looking at this given relation here, this table of values with x and y's in it, in order to establish a function, each x leads to exactly one y value. So negative 2 goes to 1 and only 1. Negative 1 goes to 4 and only 4. 0 goes to 3 and only 3. 1 goes to 1 and only 1. It doesn't matter if both negative 2 and 1 both go to 1. It just matters that they both go to one thing only. All right? So there's not a negative 2, 1 and negative 2, 2. That would be not a function. All right? So as far as this question is concerned, is the given relation a function? The given relation is a function. That's a sentence. I should start off with a capital letter. So that's the first question they asked me. It's answered. Right? Yes, it's a function. All right, second thing they asked me to do is to find the inverse of the relation. Okay, this is a new concept for you guys. You've never seen this before. To inverse a relation, all you do is you take your x and y values and you swap the order. The x's become the y's become the x's. All right, so if I'm making the inverse of this relation, and I'm a big fan of making the inverse the same type of relation. So this is a table of values. I'm going to make a table of values. So my inverse relation is going to look like this. Make an XY chart. Like so. The y's become the x's become the y's. So for each point, if I take a look at this point, y changes to x and x changes to y. So I put that for x, I put that for y, just swap the order. And I'm going to do that for each individual point. So the second point is negative 1 comma 4. I'm going to swap the order, so negative 1 becomes y, 4 becomes x. I take my next ordered pair, 0 comma 3. 0 is x, 3 is y. I'm going to make this x this way. So 3 is x, 0 is y. And I take my last point, 1, 1. I swap the order, I get 1, 1. You invert each point, and that's the inverse relation. Now the book would have you, at this point, order it with x. So put the x's in order. To me, that's not that important. I mean, that's the inverse relation. That is sufficiently the inverse relation. I don't need to rewrite the chart again just to rearrange things. I think it's sufficient to have it written like this. So that would be the inverse. That's the answer to this question. Okay, and the final question is asking, is the inverse relation also a function? Sometimes it is, sometimes it isn't. So we have to look at this inverse relation with this same idea of what a function is. Each x leads to exactly one y. What does 1 lead to? 1 and
2.
-2, right? So the number 1 leads to 2 different y values, right? In order to be a function, the number 1 has to go to exactly one y value. So because 1 goes to more than one value, it is not a function. So inverse is not a function.
But if it only went to like 1, then it would be.
Exactly. If it was like the initial relation, if it was just like this, where -2 went to one number, -1 went to number, like that, right? But since this one thing goes to more than one, it's not,
Okay.
right?
It can't go into anything on the x side, only on the y side.
Any one x value that leads to more than one y value is going to be not a function.
Okay.
Yes, Aaron?
What do you mean by it leads to it?
What do I mean by what?
It leads.
It leads to. So when we think of relations, we have an input value of x that gives you an output value of y. So the input leads to the output. So when I say it leads to, that means that if I was looking at some equation, let's say, and there's x and y in the equation, I would input x, I'd work it out to find out what y equals. So in this case, whatever made these points, whatever equation would have made these points, if I invert that equation, it would have made these points. The input of x gets me an output of -2. Input x of 1 gives me both -2 and +1. So the input value, the x value, leads to means that if I put x in, I get y out. And putting this one x in made this 2 different values of y come out. Does that make more sense or no?
Not really.
No? Okay, so I have y equals 3x. And I pick a number for x. X equals 2. What's 3 times 2? 6. So the input value of x2 leads to the output value y6. So that's what I mean to lead to that. This input gives me that output because there's some equation related to it. In this case, they just happened to give us a list of ordered pairs. They just gave us this chart, didn't give us any kind of equation with it. So this is all we have to go with is these x's lead to those y's. These inputs give me those outputs. When I invert it, they go the other direction. And if any one input gives me more than one output, it's not going to be a function.
So those 2 ones got you -2?
Yeah, so these are the same number input that lead me to different numbers output. If any one input leads to exactly one output, then it's a function. If not, it's not.
But how do you get 1 times 1 equals -2?
I didn't get 1 times 1.
No, that's
I took the ordered pairs they gave me and I just swapped them. There's no equation related to this.
Oh,
All right, they're just saying here's some random set of points.
they're saying that 1 goes into 2 if it ever.
No, they're just saying that this input gives me that output. They made some equation that has these x's lead to those y. They didn't tell me what the equation is.
Oh.
Sometimes they do, sometimes they don't. This time they gave me a relation that's just a set of ordered pairs. To invert it, I invert the ordered pairs.
It's like 4 and -1 aren't going to.
Yeah, this ordered pair is an ordered pair in this specific relation. This is the inverse of that ordered pair. All right, so they're just giving us ordered pairs, just random ordered pairs that have nothing to do with anything.
Oh, okay.
There's no equation related to it. There's a way to make an equation that makes these points, but I wouldn't know what that equation is. I have to do some high-level math to make that happen. We don't have to figure out the equation, we just have to flip the points. Okay, so if any one of the inputs gives me more than one output, it's going to be not a function. If the x's match but the y's don't match, that means it's not a function. And that's, I mean, beyond using the words leads to, that's about the only other way I can describe a function to you. Input of x gets me more than one y, that's not a function.